wants to join along, if you enter that URL right there, repl.it /@GianniLots, give that an enter. I'll bring up my repel page, and the 4 things that we're going to be covering right here. There's the exam with the solutions. Obviously, don't look at them while we're going over them. Those are for studying. You can use the exam without solutions right here. Here's the true and false if you want to fill them in as well. And then linked lists that if we do get to them, the whole full completed code is right there if you want to study that and look at that. So we're going to start with the true and false. Just some simple true and false warm-ups about concepts you have learned over the semester. And we're going to go through them and see if they are correct or not. And if not, we'll correct them or give an explanation of why that's not. So for our first one, the ++ variable operator increments the operand by 1 and uses it, whereas the variable ++ operator uses it and then increments by 1. Is that true or false? True? It is true. Perfect. So it's true because if the ++ is in front of our variable operator, we're obviously going to increment it before we use it. That is the pre-decrement or pre-increment or decrement. And the variable ++ would be to use it and then increment or decrement our variable. Perfect. That is true. Our next one, a 0 value is considered to be false, and a non-zero value is considered to be true. That's true? Perfect. That is true as well. You can use that stuff in for loops, or not for loops, while loops and stuff like that. I'll go grab the door for this guy over here. Welcome. Intro to C.
Gotcha.
Perfect. We just started going over some true and false questions. So great, that one is true. So for our third one, does the continue keyword skip one iteration of the loop? No. False, so what would it do? You want to phone a friend, help them along? Do we think that's true or false? Continue skips one iteration of the loop. Goes on through the body of the loop?
Like it keeps the loop running.
It keeps the loop running. So if we're in a for loop and we had an if statement checking something based on our counter, say if I equals 2 or something, we'll continue. That actually means we're going to skip that iteration of the loop and continue with our loop. So we are kind of continuing and skipping one iteration. So we are, yes, skipping one iteration of the loop. So that is true. We are going to be skipping that one iteration if we hit that continue statement. Perfect. So our next one, let me move this down a tad bit. Cool. So switch statement can have an arbitrary number of case instances. You think that's true or false? True. Awesome. We can have as many cases as we want for a switch statement. Doesn't really matter. I know I've done some with a lot of cases before. Not the best thing maybe, but I've definitely done that. All right, perfect. Next one. A file opened for writing already will be overwritten when a program writes to it. So this is a badly worded question. Basically meaning if we have a file open and we're going to be writing into that file from our program, is the stuff inside the file already going to be overwritten or just appended?
No, it'll be overwritten.
It'll be overwritten. Perfect.
Append is like a separate command, right? Like it's just append is A and then like so write W.
I think so.
Yeah.
So yes, it will be overwritten. So if you have an exam question with a file and they're going to be writing to it again, just always know whatever was in that file will be overwritten. And also if you're doing anything writing to files, pertaining to work. Make sure you don't overwrite any important stuff. So, next one. malloc will return an error if it fails during allocation. What do we think? True or false? True?
False.
False.
Because it will return null.
It will what?
Return null.
It will return null, not an error. The one thing we have to do for malloc whenever we are using it is to kind of hard code a little case or a catch, because Leo, you're right, if that does not actually allocate that memory space, it will return null instead of that address space. So we always do something, if that variable that we're mallocing equals null, we'll exit a program or throw an error, something like that. This is false. Malloc will return null if it fails. Awesome. Great work.
In class, the professor said that malloc returns a null. Oh, I mean, it has something to do with the pointer. Like it returns a null that.
Address
Oh yeah.
of a chunk of memory that's been allocated.
So like something about a pointer.
Yes, exactly. You can continue if you want.
The address comes from the pointer.
Yeah.
So is the address the pointer's address, or is it the address of the variable that the pointer is pointing to?
So, well, when we have a pointer is going to point to an address, a location in memory.
Variable.
Yes, not another variable. It can be a space in memory. We're just allocating that space. So a pointer is going to point to that memory location, and malloc returns a memory location. That's why.
Who holds the address?
The pointer is pointing to the address. The address is somewhere in kind of whatever way you want to look at it.
It doesn't belong to a variable, it's just the address.
It is just an address, and then that pointer will point to that. So it kind of has access to it if you want to think about that. So anything you do, the pointer will actually in turn affect that address space. So whatever way kind of helps you think about it. You can think of them, I always think of them, if I have a pointer pointing to an address space, they're kind of linked together. So whatever I do on one end will happen on the other. So if I have a pointer equal to the address of x, and then I increment that pointer, x will also be incremented, because they're kind of linked together. Good? Any more questions on that? No? Perfect. So next one. An advantage of a linked list is to be able to perform random access. Is that a true or a false statement? It is true. And why is it true? I don't know. Does anyone agree or disagree with that?
I mean, because linked list can be located anywhere in random access memory.
So let's think about that. They can be located anywhere. Are they contiguous?
No.
They're not contiguous. So if they're not contiguous, in my head, it's kind of hard to randomly access any part of that since it's not in a block together, whereas an array would be in a block together and contiguous. So we can kind of randomly access any part of that memory, whereas a linked list is kind of spread out all over the place and kind of only linked together by those pointers, so they can be really far or really close to each other. So this is a false statement, meaning we cannot really, it's not easy to do random access with a linked list. So this would be false. Is that what you're going to say, Christy? Okay, perfect. So false and not easy. Not easily able to perform random access. Cool. So our next one, dynamically allocated memory is created at compile time. Now this goes hand in hand with the concept of what is dynamically allocated memory and why do we use dynamically allocated memory rather than static memory. Compile
Borrow
time.
as much as you need.
Okay. So would we borrow at compile time?
Before compile time.
Not before compile time. We would do it at runtime. And that's the whole concept of dynamic. So when we don't know how big of our array is going to be, we can actually compile that at runtime based on a user input to make that array that certain size, like we did in our SI lecture today.
What's the difference between compile time and runtime?
Compile time is when you click that run button, everything that is needed to be allocated like a static array will be compiled then. It will allocate the space for that, whereas a dynamic, it can actually be compiled while the program is running. So with like a linked list program that uses functions, if the user says, I want to add a node, the program is still running and it's still going to add that node. So it's created at runtime, meaning every time we call that function, it will malloc that variable right then and there as it's running. Good? All right, perfect. So this one was false. It is allocated at runtime. Awesome.
Oh, and also like malloc is a function, so that makes sense.
Yes, malloc is a function. So next one, a function cannot be defined inside of another function.
True.
True. Awesome. What can we do with another function inside of one? We can call it. We cannot define them, but we can call it. This one is true. Awesome. You got that one fast. Okay. Our next one. Functions can be called either by value or by reference. We should know this one. Actually, no. I reread the question. This is a little confusing if you do not know. Can we call a function by reference?
That's true.
Why is that true?
Well, like, I mean, like it's flexible. Like you can, like if you had a, if you have your parameters as non-point, if they're not, if your parameters aren't pointers, then it's called by value. If your parameters are pointers, then you would have to do call by reference in the main.
Okay. I like your way of thinking.
It's flexible.
It is flexible. I like that. This is true. We can call functions by value or by reference. So this is going to be a true statement. How you doing? How you doing? So you can sit anywhere. Those are surveys on the thing. They're going to have to be done at the end. So just look through them as they're doing it. Watch yourself so the recording doesn't get. All right. So our next one. We can only access dynamically allocated memory through pointers. Is that true or is that false?
That's true.
It's true, exactly. Pointers and malloc or dynamically allocated memory goes hand in hand because like we just said before, that pointer needs to point to that memory space that we allocated. Awesome job. That is true. And I'll move this guy down a little bit. All right, second to last one. We can use free to allocate memory to static variables. This is not supposed to say free. This is supposed to say malloc, sorry. I read that and I was like, what? We can use malloc to allocate memory to static variables.
Static, like const?
Static meaning non-pointers.
Oh.
Like something like an int a. Sorry, the wording was a little confusing.
That's true.
That's true.
Like
So.
like if you pick, like if you want to declare, if you want the user to enter the size of the array. Oh, never mind. It's false.
False.
Yeah. It's false.
Just the same thing.
Arrays are pointers, yeah.
The same thing I just said. Dynamically allocated and pointers go hand in hand. So something like just regular int a like this. Int a, we will not be able to malloc that. So this is false. Pointers. Dynamic. And our last one.
False.
Null can be assigned to static variables.
False.
It is false. Do you know why false?
Because I've never seen it assigned to a static variable.
It would give you an error? Okay. I believe it would, yeah. I'm not sure if it's a warning or an error. Let's spell this right. False. Awesome. So no, they cannot be assigned to static variables. Could someone grab that door? Oh, we got someone. Thank you, Jack. Okay, so that was true and false. We're going to be moving on to our actual questions here. And for the people that just came in, if you want to follow along, you can use this little URL. And the thing we're about to be doing is right here, study union exam without solutions. So if you want to type your own answers in and stuff like that, you can. Question, yes? Dynamic meaning we can modify them and manipulate them while the program is running and stuff. Yes. So in terms of malloc, we can kind of do that with anyone that we malloc, in a sense. Awesome. So, cool. Can everyone see that, or do you want me to zoom in a little bit? Good? I think that's pretty good. Okay. First easy question. What are 3 ways we can return values used in functions back to main? Yes?
So you have call by value, call by reference.
Pass by value. Pass by reference, you said? And the last one. This is a big no-no. I'll give you a hint.
Oh, it's no? I mean,
This is, you can do it, but it's kind of shunned upon.
oh, hard
Global, exactly, perfect. Global variables. Pass by value, pass by reference, awesome, do that whenever you want. Global variables, very iffy. A lot of people would not like that if you did globals, just because you can kind of modify global variables really easily and maybe mess up something else in a separate section of your code. So move on to some string questions. So this one, how can we tell when we have reached the end of our string in an array? Exactly, our terminating character. So our terminating character is our little /o. Yeah, I just missed the single quote button. Yeah, now it's going to do all this. Yeah, so we have our single quotes. So that's our null terminating character, and we can search for this. We can have a little condition. Once we get to that, we know that's the end of our array. And we can also use something, string length, I believe, to get that last character in the array, or whatever in the array, and we can use that number as well. So next question. Give an example of initializing a string using an array, meaning the brackets, and then a pointer, so without brackets. How would we do that? Yes?
So for example, you could do
Char.
char star, the little star thing.
Mm-hmm.
You do like name,
Okay.
variable name, no name. And you could initialize it to, well, yeah, you can initialize it to, let's say, in curly brackets, and then like double quotes, and like empty space, and then like semicolon.
So we can put
You could,
like that?
yeah, you can do that.
Okay. And how would we do that with an array? How would we initialize with the array? I also have my notes saying we should do it like this with a pointer. And the other way, with an array, we will do, I'll just make it 10 for no reason, and then for this one, I'm going to be using our curlies. And we'll put hello, something like that.
When you launch strings, you can just not declare the size of it.
What was the question again? When we're declaring,
This is character string. You always need to specify the amount of characters.
there's specific ways to initialize a string where you don't need to specify, and we'll see that a little bit later on. But most of the time, yes, you should put your little size in there. And what's better, to have a size just the size of our string that we need, or should we have a very, very large one for no reason at all? What's better to do in practice? A very, very large one. Yes, we also need room for our null terminator, and also, if in the case you're not the only one using your program, having a very arbitrary large size for your array can account for any kind of size input that the user is going to be putting in, so we don't encounter a buffer or overflow or going out of bounds of our array. So it's always good to have a really big array just in case, because we don't know what that user is going to be entering into our code. It's always good to do a defensive code rather than a non-defensive code. So yeah, that's the way we're going to do that. So for the next one, please list the types of string functions and what they do. We're only going to be covering the main ones that we covered in Avellino's lecture. So let's see if you guys remember some of them. Okay, so we'll start with a string compare. And what does string compare to?
That is like that precedes the second string's letter, like alphabetically.
Mm-hmm.
Then it's going to return, I believe, a positive number, a positive like one, for example. And if the second string, now if it's the other way around, vice versa, if the second
Mm-hmm.
string has a letter that precedes the one of the letters in the first string alphabetically,
Mm-hmm.
then the string compare will return a -1.
Okay. Awesome way of describing it. In my notes, I have it returns a negative number if the first comes before the second, lexicographically.
Oh, so I had it backwards.
Yeah, you had it perfect definition, you just had them mixed up a little bit. So, like we just said, we're going to get a negative if first letter comes before. And going to have one more. This is going to be a positive. And that is going to return if the first comes after the second.
Johnny,
Yes.
for line 19, the string that you initialize can have up to 10 characters.
Yes.
Have 10 or less than 10.
It can have less than 6. If we were in the SI session today, we actually kind of went over this question. Oh, wait. We're not done with our string functions. We have more than that. All right, who has another string function for me? We have string comp. What was that? String copy. Awesome. Very, very useful one. So what does string copy do?
It copies the copy, so you have two strings, string 1, comma string 2. So it's going to
Yep.
copy the string 2 onto string
Perfect. So like Leo just said, if we have stir1 and stir2, if we use that, string 2 will be copied into string 1. So copies the second string into the first. Copies the second string into the first parameter. Awesome. Why would we need to do that? Oh, yeah, sorry. You're right. Thank you. Screen's a little bit hard to see up here.
Are we going to go over all the string functions?
Just the main ones we covered in class. So I had a question, why is string copy useful? Why do we use string copy? Very important concept of why we need to use string copy rather than just an assignment operator. Perfect. We cannot assign strings. So if we wanted to assign a string to a different character array or something like that, we would have to use string copy. Because we cannot use the assignment operator, our little equals, for...
Could you write that in there?
Excuse me?
Could you write the reason in there?
Oh, yeah, sure, I can write that reason.
I'll copy and paste everything.
Intro to C? Intro to C? Intro to C?
Section. This session is intro to C.
Yeah, for the programming.
Yeah. Awesome.
I have a question.
Hmm?
He's a tutor, right?
Excuse me?
He's a tutor?
Yeah.
Okay, technically I already did my final, but I just need help with something else, like after this probably? Do you think you're able to?
Probably not. I have a time schedule I need to end and start on, so maybe I'll talk to you after. It will be at 5 o'clock though. So the reason we cannot assign or use the assignment operator for strings. Cool. You guys good on that? Cannot use the assignment operator for strings. And who's got another string function for me?
Say string char,
What was that one?
strchr.
String car?
String car.
That was not one of the.
Okay, string cat.
Okay. Okay, we'll go on string cat then. So string cat, what does a string cat give me?
Literally adds like the second string to the first string.
Literally adds the second string to the first one. Exactly.
Assuming that you had str1, comma str2 like that.
So I'm just going to put concats the second argument to the first argument. Everyone good on that one? There's also one other thing. What was that? str string length. Okay, and what does string length give us?
Captures the size of the string.
Returns an integer, perfect. The size of our string. Awesome. So we have string compare. Yes, question? No, if you should have to, the only way you can access this is if you fork the actual file, so it should be independent of mine. At least that's what I think so. We'll find out, I guess, after this. 1, 2, 3, 4. Okay, string compare, string cat, string length, string copy. Awesome. Now, back to what I was just saying about our SI session. How can we create an array of strings? A character array. We're going to need a character array, yep. Is it going to be any ordinary character array, though?
Double pointer.
We can do it with a double pointer. That is one way. And a 2D array. Awesome. We can do it that way as well. So I'm going to start with the double pointer because that's what we said first. So one way we can do it is just have a double pointer to that, and then we are going to malloc just because I want to add some DMA into this, and we'll use the size of what? What are we going to be putting inside our size of?
Char single star.
Char single star. And does anyone want to explain why we're using that char pointer? What was that? Okay, we got a no idea. Why is it not 2? That's also a good question. What was that?
Different data types are machine dependent on the number of bytes that they take.
Oh, they are, yes. But the main reason we're doing that as a pointer is because the first pointer would be our kind of our array. Then each index of those pointers would be our string. So each index can hold a separate string. So we can malloc it like that to create an array of strings. I also heard a 2D array. So we can do something like that, just make a 2D array manually and do them. And there's also one that kind of combines both of them. Char suite. And I will put a bracket on here. Actually put the length in there, the 4. And then inside our squiggly, we can have 2, 3, 4. We can have 4 separate words in there, and we can put what we want in there. So diamonds, spade, and so on and so forth. Perfect. So now we're going to get into our arrays and structs section. We covered this a while ago, I think at the beginning of semester. What do each of these array initializations do? Each does something a little bit different, and they're all pretty useful. So the first one, we have an integer array with size of 10, and it looks like we have 10 things inside of our squiggly brackets. Yep.
So the first one, all 10 are known.
Mm-hmm.
For the second one, the doesn't have 10 points.
Well, they're all known, so what does that
Well,
mean?
I mean, like if it's not shown, like for the second one,
Mm-hmm.
if it's not shown, then it's 0.
Okay.
Yeah.
So based on what Leo just said, the first one, we have 10 integers inside of our little.
Non-zero.
We have 10 non-zero integers, so this means all of these are going to be initialized. I'm just going to put init, so I don't have to put initialize every time. So all of them are initialized, and based on what Leo just said again, since we have the size here to be 10, we do not have 10 actual things declared in our little squiggly brackets. So all the things that do have numbers will be initialized. You say it will be null? So does that explanation make sense to everyone? All numbers are going to be initialized except the ones that are remaining. So the 1, 2, 3, 4, 5, 6, 7, 8. Is that 9? 1, 2, 4. That's 8. So the rest, the remaining 2 will be 0 in our array. So if we have a size declared and we do not initialize as many of those as our size, then the rest will be put into 0 in an array. Everyone good on that? Awesome. What about this guy right here? There's an implicit initialization?
I mean, implicit size.
Implicit size? So you're saying when I run this code, it will automatically put a size in there for me? I think so. I got a lot of I think so's. You're actually right, yes.
Oh, yeah?
So all of these will be initialized and the size will be set to 10. Awesome. Perfect. And our last guy, easiest. Everything to 0. Awesome. Everything initialized to 0. Perfect. So a little two-dimensional array action. What indices are initialized with this array declaration and I guess initialization? So we have a double array called C, and we have a length of 2 by 2. We have in our square bracket 1, 2, and then 3, 4. So let me list these out real quick. C0, 0 will be the first one. What will that equal? 1? 1, 2? Just 1?
Oh, yeah, just 1. My bad. Yeah.
Just 1. Okay. Perfect. So if we do that, we can grab this guy. Yeah. So this means 1, which one will this be? 0, 1 or 1, 0? I guess it doesn't really matter. I'm going to make this one 1, 0. We'll make the other one.
All in one row. But if you put 3, 4 right under 1, 2, it'd be.
Yeah. Okay. I'll do. You're right. It would be clear. And what's this last guy? 1, 1. Awesome. And these do not all equal 0. This one will be 2, like we said. This guy 3, like we said. And our last one at 1, 1 will be 4, like we said. Perfect. Awesome. So we learned this in class. 2 of them are not really needed. The other one we use all the time because it's a little bit easier. So the question is, what are 3 ways we can declare and initialize structures? Guys, in Avelino's lecture, we know there's 3 ways that we need to know, but we only really use 1. Yes? So our first one is using typedef. So we're just going to do a typedef struct, and do we need a name for our typedef? No, we don't have to use a name for our typedef. Awesome. So that'd be something like int data, and then, is that it? That's all a struct? The thing at the end, what's that thing at the end? We do need a semicolon at the end. Variable name. Awesome, awesome, awesome. So I'm just going to name this var. So with the type def, that means everything that was defined in our structure is now renamed as var. So we can do something in main like var ice cream. And we can make it a pointer if we want. So that's how we would do initialization of that inside of main. So we'll put a little thing here inside of main. Cool. Awesome. So that was the one we are mostly always going to use, type def. Just makes it a little bit easier for initializing other structs and stuff like that. So we don't have to put the struct keyword every time. Make it a little easier on ourselves. So what was one of the other two ways? So use a struct and then name. So name, what do you mean, like right here? Well, that would kind of be the same thing what we just did here. So struct in the name. So struct something like that. The tag of.
But it's just that you can't like use it later on if you don't have it.
Okay.
That's why you want to have it.
So we want that node, so we can use that later on. Okay, so I'm just going to put the same thing in here in data, just so we can have it. And how would we make instances of this one?
Same way.
So we need our semicolon. So every time I want to make an instance, I would have to do struct node and then our name. And would this be in main or before main? Before?
It would be in main.
In main. I'm not sure about this one. The next one, though, is not in main, if that gives you a little hint.
Why aren't there any instances?
Instances in which one?
In the second one, struct no. Why don't you just have a semicolon? Where are the instances?
That's the next one.
Oh, you can't do it like the var in line 25. You can't do that. Not for this one because there's no type def.
I'll show you in this one right here.
Oh.
So our last way is kind of the same thing. We'll just put the same exact thing in data. And then in this one, we actually are going to be using this right here to do our initialization. So I guess we'll just put 1, 2, and we can have 3 as a pointer. Like that. So that struct will be initialized. We'll have 3 of them. We'll have 1, 2, and then 3 as a pointer. And is that what you're talking about, Leo? Having the instances right there where var is?
Yeah.
Awesome. Yes, so those are the 3 ways we can do our structs.
They all do the same thing.
Oh, yeah. It's just one's easier to kind of use. Like in our type def, we could just use var every time. And
Your line 72, how come you don't have a name for that struct? You just have primary struct.
so this is equivalent to that. For type def, we do not need a name for it. But now, if you were doing a linked list and you were using type def, you would need a name so we can self-reference that node. Makes more sense now a little bit? So now we can self-reference this. Exactly. So in a linked list, we would need that name so we can self-reference it to make that next pointer. Awesome. Good work. This one, we should be able to get this one. What is the key difference between the dot operator and the arrow operator?
for static variables, but the arrow operator cannot be applied.
So the dot operator would be used for a struct, that is not a pointer, right? So we'd be using the dot operator on something, or struct, or an instance of a struct that's not a pointer. So if we just have a regular struct. So we would use the dot operator on 1 and 2, because those are both not pointers.
So you can do like one dot data. Right?
Yes, yes, exactly. And our arrow, exactly the opposite of this. We're going to be using that used on structs that are pointers. Because, like you said, yeah, dereference them. So on 3, for an example, since that was initialized as a pointer, we would use the arrow operator on struct 3. Perfect. I don't think we did a whole lot of stuff on multi-file programs, but we'll delve into it a little bit. So how would I add another file to my program? This file can be anything. It can be a standard C library, it can be a header file that I created, or it can be any of the above. What? Include, awesome. So we have the include. We see this on every C program that we write. So the include, I actually found out there is 2 different includes. So if we do this, include with the little sideways carrots, that is if the file huh? Yeah. Yeah, it is. It's the whole semester. It's not commutative, but there's other people in this that do not have their same professor. So their final may be commutative. It can be anything, header file, C file. So this kind of encompasses everybody, and that's taking the thing. And then the other one include, we use this, our little quotations. So we use our little arrows if it's not in the same directory, and our quotations if it is in the same directory. If you were at my last review, we covered this one. What is scanf suppression and how is it used? This is something that was briefly covered in our lecture. What is scanf suppression? It kind of gives it away from the name. Okay, perfect. So it suppresses a character when we're scanning to take in maybe 1 and 3 instead of 2. So if we were taking in a date or something and we wanted it in a certain format, we could omit the year or the something. Yeah, exactly. So yeah, we kind of just briefly did it. So if I'm gonna open up this guy. So if I had a print statement, enter 3 numbers, it's A, B, and C. I'll do a scan of these. And we're going to scan that one in. And this one in, and this guy in, and we're going to scan them into A, B, and C. And let's do a little print of these so we can check. And %D, 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 and we'll print out A, B, and C. A what? Is there an error in here? Okay. So what would I do to this scan to suppress our second one, so our B? So percent or percent Ds. Before it? So that guy? Do you want to come over here and type it out? I'm having a hard time hearing you because you're facing the other way.
Sorry.
Yeah, you're fine.
So it will look like this. So let's say like you want to write the date.
Okay.
It'll be like that. Wait, I think.
We can run it and see.
I don't know if you see or so like if you want to put a date like like that.
So we got all of our numbers. So what did we suppress? We suppressed the hyphens. Awesome. So we suppressed our hyphens like that, or we can do something like this. And if we put our little asterisks right here, I believe if we do 1, 2, 3, yes. So we are suppressing our second input. So we entered 1, 2, 3. 1 and 3 get actually scanned in, and then that third thing they print out is a garbage value, meaning it's just nothing, basically. So we suppressed our second one.
You're going to have 3 numbers no matter what.
Yeah, something will kind of be put in that last variable, but we don't need to print that out if we don't want to. We could just print out A and B, and then we can be all good.
So you type in something too, right?
Yeah, so if I scan it again, I'll put 101, 202, 303, and I have 101, 303, and 24. So that last one was not scanned in. Or the second one was not scanned in because we suppressed it. Awesome. How can you open a file and read the contents?
So what you would do is you have to create one first.
In this case, we'll just use the thing. We're not actually going to have a file because I don't have a file on hand for this. So what was that? I heard a file.
You have to first do all caps file.
File.
Yeah, like whether let's say FPTR.
FPTR.
Then you would have to create. I think yeah, you just created a folder. Should have file. The open equals fopen.
fopen.
Yeah, now you enter the name with the name quotation marks.
So the name, file name. W is right. R is to write, or read, and what was the append? A is to append. Awesome. Everyone agree on that? One thing we're always going to do, just like our malloc, just in case, is if this ever fails, we should put a catch in here. So if this returns null, meaning it didn't open the file, we could put up a little print. And we can put a little error message in here. Just in case, so we can let ourselves know if that ever happens, the file is not open, then we can see it and catch that error. Awesome, good job. So adding on to it, how can we read an integer from a file we have opened? So the file is already opened. How are we going to read an integer from that? In line 7, yeah. What's the same thing?
To answer how can we read integers from a file.
Well, we're going to need line 7 too, yes.
So typecast?
Don't really need to typecast. fscanf. And the difference between scanf and fscanf is fscanf is for files. Awesome. So the parameters of this are a little bit different. To remember what they were. So the pointer first, file pointer we have. %d, because we're going to be scanning in an integer, and our last thing is what we want to, or the variable that we want to scan it in. We could just make an x, even though there's not an x, and x. And that's how we would scan in a integer from our file. Yes. Great job. So the fun stuff. Dynamic memory allocation. Now, this is what your final starts on, right? For Avelino, at least? Okay. So first question, in what scenario would we use dynamic memory allocation rather than just hard coding everything? Or, you know what I mean. We don't know what our arbitrary n will be. So a simple example would be when we don't know the size of the array needed. So very simple example. We don't know the size of the array that's going to be needed. I used this example in class today with names, meaning there's a program, enter your name. If I have a name that's Tom, I only need a space of 3, whereas actual name Gianni, it's going to need more than 3. So that program can catch both of those cases. We can make an array with size 3, or we can make an array bigger based on that name size. So that's when we use something dynamically allocated, and it's very, very useful. So if the pointer to a dynamically allocated section of memory is redirected, what happens? So that means we have a pointer to something, and then we're going to redirect that. The memory space is lost, exactly. If we allocate that, and we lose the pointer to that, that memory will be floating around somewhere in our program space. So if the pointer is deleted or redirected, we will lose contact with that space. Cool. So if we ever modify or redirect that pointer, since we have no way of getting back to that memory space, it'll be gone forever. And that's why in a linked list, it's very important to keep track of your head, because if we don't have our head variable, then we don't know anything on the prepended side of the head. Or if we modify our head, then we lose everything that before it was modified. So next one. What is something the programmer should always do when working with allocated memory? We just did something like this with our file. What was that? Yes, we always have to free that when we're done using it. Yes, that is 100% something. I'll just include that so we can free the memory. And perfect, I heard my answer. Always check variables for null. Awesome. I always want to check the allocated memory for null. So if I'm going to be having an int a equals malloc size of, I'll just put an int in here. Then I want to make sure this variable does not equal null. If it is, I'm getting out of my program. I don't want to continue. That's very important for linked lists, because if we allocate a node that is null and try to add it to our list, then we're just pointing to null basically, and we don't know where our list is. So we always want to check, because that can be very devastating to programs, especially when they're running by themselves and you can't really see what's going on. Awesome, awesome. How do I know how much memory to set aside for each block of memory to be allocated? So if I want a character array, how do I know how big I should allocate that memory size? What was that?
You can like set the number, like doing the character array to like a variable.
Okay, so we can set it to a variable. So we can be, if n is the size that the user is inputting, we can put n times what? What is the other main feature of malloc, or what do we need in malloc? Size of, exactly. And combining what we just said, if we wanted to do character array, size of car. And I'll just add to the beginning of this so it makes sense. Char array. So if n in this case is 10, how big of a block are we going to be allocating? 10. Basically, the array says 10. Awesome. So do we need that n for our malloc every time? Nice.
You're already declaring it outside.
Yeah,
Exactly.
So it works.
It's gonna give you compilation error.
Compilation error. Now we change our answer. Does everyone want to go compilation error? Okay, so it's going to tell us we have two variables that are redeclared. Infinite loop.
No, bro.
I don't think it's gonna compile. Yeah.
I don't think
So we're not going to compile. Is that the answer we're leaning towards? We're not going to compile? All right, let's check it out. Oh, what happened there?
it would run 5 times because like that's what the I is for. Yeah, it's inside the for loop, so it'll run 5 times.
So this is a test on scope. If you know your scope, this integer I is completely independent of the one outside of the for loop. Anything that is initialized inside or declared inside of the for loop, once that for loop ends, it disappears. It does not have any scope outside of that for loop. Meaning that I is controlling, the first I in line 6 will be controlling our counter, and I in line 9 will be our actual 404, and that's what we're going to print out 5 times. So those are two independent things. They have different scopes, and that's why it works. Any questions on that? So we know we can have two integer I's. Yes.
So that I in line 9 is local to the inside the for loop.
Exactly.
Oh.
Perfect wording. That is local to the for loop. Whereas int I is local to our main. Good. Any more questions on that, or?
Did you like if you didn't initialize the I like outside the main, can you still do what you did like in the for loop, like you know?
So if you're saying I get rid of this I,
The one like outside.
if I got rid of this one, what do you think? If I got rid of that line 6, are we still going to run? No. Exactly. I is undeclared now. Yeah. We would have to declare it before. Now that would give us the compilation error. Yeah, we're basically just making a new one in a different scope. So last, oh, not the last, second to last. Okay, so we have an array, we have a pointer, and then we have a I equal to 2. So it's going to what? It's going to print the number 3. That's our. You guys get an answer on the left side?
Why did you put comma like I equals to like
On line 9?
yeah, just like the comma.
I will explain after we get an answer. After I run this guy, I'll explain. We'll cover that. You think 3?
Yeah, you have a pointer and it's 6 plus. I think it's not the
Great. 2? So we got 2 and 3.
No, it's 3. It's gonna be like the second like level 6. 0, 1, 2.
We got a 3. You guys see why we got a 3? No? All right, let's go through our explanation. So in line 8, we are assigning our pointer to point to our array. Keep note that I equals 2 up here. So when we go down to print an array, you can dereference that pointer and then just add a number or variable to keep going on in our array. Any other questions on that? So single point, okay. So we have an all 10 answer. Marco, you should get this one. That was the same question as like the last exam.
Yeah.
I'll give you a few more minutes for people to look at the code, traverse through it, see what's happening.
If you have single stuff, double pointer, you're gonna print the address of single pointer. Whereas if you have 2 stars for double pointer, you're gonna actually return the value of the address of x.
Yes, because double pointer is pointed to single pointer, which points to x. Yes, that's almost the exact. Yeah,
It's like
this one's connected to this one.
Not really.
Yeah, maybe a small one, because like x is here. This one's pointed to x, and this one's pointed to that.
But like there's gonna be a linked relationship.
Yes, a linked relationship if you want to look at it like that. Because basically, if we get double pointer, we can see single pointer, which sees x. Every time you do that, I think you fall out of your chair. The little, when it goes like this. I always think you fall out of your chair when you lean back. Are you guys drawing that out to keep track of your pointers? Awesome. Always good if you're doing a test or anything, you got multiple pointers, draw it out. Visually, it makes it a lot easier to look at something on paper than kind of do it in your head. Especially with arrays, 2D arrays, linked lists and stuff, drawing them out can help too. Visualizing is a lot easier than trying to do everything in your head. You will get confused. You do it for linked lists, drawn out?
I accidentally clicked fork my REPL. What does that mean?
So fork means that you're actually going to take that REPL and then you can use it as your own so you can edit it. You shouldn't be able to edit them right off the page.
Fork your REPL?
Yeah, and then you can modify it however you want. So that linked list REPL that I have, you can take it and add to it, delete from it, whatever you want. But you have to fork it. You guys still discussing on the left side there? No? You guys got it? What is it? All 10s. Everyone is on point with their double pointers perfectly. So double pointer is going to be pointing to single pointer, which is going to be pointing to x. So when we print them all out, we get the same exact thing. Awesome. Good job. So that is it for our coding. Now we just have programs to do. What was that? Insertion? That is our last program. Do you guys want to do our insertion? Everyone okay with our insertion sort? No? Which one do you want to do? So you want to do it? Okay. That's great. We could do that. So let's copy this guy over to our workspace. Let's paste. Let's do a. I emailed him and he gave me a just some concepts that he would like me to cover, and that was kind of about it. He hasn't, like he said in lecture today, he also hasn't written up the test yet. So even if I went to meet with him to ask him what questions I should go over, there nothing really I could get out since he hasn't really made the exam yet. So. Since you're only covering insertion sort, I would just be familiar with how it works and stuff like that. And he also said the complexity of best and worst case. Whereas in CS1, you may need to memorize, different searching. So you can, from code, just look at it and see, okay, this is insertion, or oh, this is merge from the code, like how it's based and how it looks. So once you kind of learn how each sort works, it should be really easy based on the logic of them. So for this one, I would say that and binary. He also said binary, just the concepts of binary, how it would work. So before we get into this, let's do a little binary search quiz. What can I use a binary search on? Sorted arrays, not just any array. We need a sorted, because if it's not sorted, we won't know where to break that list in the middle. And basically the concept of a binary search is if I have 1 through 10 and I'm looking for 3, I know 3 is not greater than 5, so anything that's on the opposite of 5, 6 through 10, I can completely delete that from my search because it's never going to be in there, and now I have a smaller search place, 1 through 5. And then I can do 4 is bigger than 3, so I'm not going to need anything on the right side of 4, so I delete everything on the right side of 4, and now I have a smaller one. And I keep doing that until I get my 3. Very fast, very efficient. So for our insertion sort, I already have this thing coded up. So I'm going to include our little prototypes firstly so we can see what we're doing. Both of them are going to be voids. I'm going to have a printing array, and I'm going to have the actual insertion, like so. And the print array is going to be taking in an integer array, and we're just going to do an int for the size, and the same exact thing for our insertion sort. And an int. Cool. See if we have any errors real quick. Nothing. Awesome.
Generate random integers to store in an array. It won't be ordered. It won't be in ascending order though, because like it's random. So then we gotta like sort it.
What, for binary?
Swapping. No.
Insertion?
For sorting array.
No, the whole point of this is I can have an array like you'll see right here. If I have int r, and we'll do 5, 3, 7, 6, 2. So that's not sorted, right? So it is not sorted. So the length of this n is going to be 5. So we have 5 elements in our list. So we're just going to keep that. So we have a size. That's always doesn't have to be hard coded in. We can always use a length function to get the length of that array. So we don't always need to hard code that in. And then, what was that? Yes. There is a way you can get the size of any though. I forget what the function is. There's a way to get the size of that array. I'm blanking out now. Now that you asked the question. Then this is going to be very, very easy. I'm just going to put all of our calls right here, just because I know we're going to be using them. So insertion sort is going to be taking in that array, the one I have, and the size, just like it's denoted in our prototype, and this is going to be taking in the same exact thing, our array and our size. Error saving failed to fetch. What was that? This is going to be printing our array. So once we sort it, we can print it. I'm not sure what's happening with this. I'm just going to copy everything just in case this explodes when I go back, because it's saying failed to fetch. It's not letting me rerun my program. Well. What the? It's only for visiting guests. All right, let's agree to this. I'll do it on the other one. Please let me back, thank you. That was very strange. Oh, it did fail to. Look at this, got rid of everything. There we go. All right, cool. So we only have those two errors because we don't have our definitions of our function yet. So insertion sort is really the big one. So this is going to be a void insertion sort, and like I said before, we're going to be taking in an array. So we'll call it R, and int n for our size. We'll just rename the same thing because why not? So the first thing for our insertion sort, I'm going to need a counter, something to store a key, ket, and another variable to store our other counter, because with insertion sort we're always going to be not on the same index. So does anyone know how to start our insertion sort? For loop, awesome. So let's start this in a for loop, and key is going to be the thing that's taking the value of that index, so we can compare it to something in front or before it. Yes, we are going to be using 1 for I, and that is because we want to check the thing behind it as well. So we're going to do an int I, and what's I going to go to? Less than n, perfect, and increment. Awesome. So we have a for loop, and an inside. I'm doing mine a little bit different. You can do it with another for loop. I'm going to be doing it with a while loop, so you'll see a little different way of doing an insertion sort. Both work. But before I do that, I'm going to make our key equal to the array we are on, denoted by I. So the first run key is going to be equal to the first thing in our index, or the first index, not our 0th index. So key is always going to be 1 in front of the 0 index. So as keys, so the insertion sort works by comparing the one before it to the one in front of it. So we want one that's going to be pointing to the one in front of our first index, so we can compare them to.
Couldn't you just use like an if statement to like because you want them to be in ascending order, right? So
Yeah, we can. I don't know about doing it with the if statement. You probably can. I'm doing mine with a while loop.
Oh.
So we have our key equal to our I index, which in this case is 1. Where's my cursor going? What the? Okay, there we go. And then I'm just going to be making x equal to I minus 1, because x wants to be that first one, so we're going to compare the first with the second. What do you mean? Because I know I need the size of my array, and I know I'm going to need array, the one to be sorted.
So the order doesn't matter, right? You could do n array.
Yeah, sure. Doesn't matter. It's just how you set it up.
So you know to have those parameters in there, because like when you call it in main, you're gonna have to let those.
Yeah, if you see right on line 14, I called insertion sort. I'm bringing that array in there, and then the n, which is the size, and the array is the unsorted array.
Line 22, you can call those parameters whatever you want. It's just
Yeah. Yes.
that on line 14, the R and the N will play the roles of those parameters.
Yes, exactly. I can rename what Leo is saying is this this AR and this N over here can be renamed to anything, and this AR will take the place of this one, and this N will take place of this one. So this can be Bob and Sally if I really wanted to.
If you have two parameters on line 22, you have to have two something up there when you call it, right?
Yes. Also reiterating for people watching on the stream, if this int, we have two parameters for this, my function call is going to need two parameters as well, and also my prototype is going to need two parameters as well. All of those three things need to be in sync. So in our while loop, this is what's actually going to be doing our little swapping or inserting, if you want to think of it like that. So while x is greater than or equal to 0, in this case it is always going to be because it starts at 0. So that's going to equate to true. And if our index of 0, in this case for our first loop, if our index of 0 is greater than our key, and remember the key is the index 1, meaning our second thing in our array. So if index 0 is greater than index 1, we need to obviously swap them. And how we're going to do that is we're going to do r x plus 1, 0 at this time. So r of 1 is equal to r of x, which is 0 at this time. So that's going to transfer those two values. And then we're going to do in little shorthand. What does that mean? Does anyone know what that means? Yes, decrement by 1. So it's basically the same as x equals x minus 1, just a little shorthand. So once we have that, we're going to be done with our while loop. And now that we have our things swapped, the only thing we need to do is put back our variable. So we're going to do x plus 1 again equal to our key. So basically we're swapping the ones that need to be swapped and then putting our value back into the one that's has to be in front of the previous one, if that made sense. So let's make sure we don't have any errors. Undefined reference to print array, that's fine because we have not defined our print array first. I'm just going to type this print array function pretty fast because it's really really simple. Oh my. Print r. So the parameters I'm going to be taking in are a integer array, same thing. We'll call this r and we'll do n again. Same exact thing. Doesn't need to be, but it can be. So in here we're going to have an int I, and we're just going to have a for loop. For I equals 0, I is less than n, just like our other one, and I plus plus. And then for each of this, we're just going to be printing out. Very simple function. And we're going to be printing out an integer. And what we're going to be printing out is r of I. And what is this guy linked to? What are you doing down there? Oh, you're right. Thank you. That would have been very silly. Hold on, let me get this in the right spot here. What was that? 44? After 44? Oh, yeah. Thank you. So I'm just going to be putting the space in here so we can see our numbers. And there we go. We started with our array 53762. And let me minus this, or get rid of all this white space so we can see most of our function. We're not going to be able to see all of it, but we might be able to get, yeah, we got everything in insertion. So basically it just takes it, compares the second one to the first one. If the second or the first one is bigger than the, from the first one is bigger than the second one, they're going to swap. So 2 went all the way to the beginning, 7 went all the way to the back, and we have a sorted array. And like I said at the beginning, that n doesn't need to be hard-coded. We can always ask our user how big our array is or whatnot. So that is our insertion sort. Pretty simple. The next thing the question asked for was to give the complexity and the best and worst case scenario for this algorithm. So we covered a little bit of this in class. I'm just going to go down to the bottom here and do our complexity. Does anyone remember what the complexity of this is? It's not that good, or not that good for runtime. Thank you very much. Have a good one. Good luck on your final. Have a good one. So what was that?
N times n minus 1 over 2 or n squared.
Yes, it is very close to n squared. So complexity, oh, what the? Let's not do that, n squared. So meaning if we have an n value of 100,000, this program will take a pretty long time to finish because it has to go to that squared, which is a very big number. And our best case, we covered some of these in class, and our worst case. Worst case. So what's our best case scenario for our insertion function? It's already sorted. So array is already sorted. This is insertion sort. So our best case would be the array is already sorted, meaning we go through one pass of the array, we see everything is less than the others, and it's in sorted order, and that's our best case. Our worst case is what?
Reverse order.
Reverse order, exactly. The opposite of our best case is in reverse.
So like descending order, you say?
Yeah, so if it was 7, 6, 5, 2, 3 instead of 2, 3, 5, 6, 7. That would be worst case because we would have to go through our array that many times to move 7 all the way to the front and whatnot.
The only thing that would happen is if you did your whole like not for your while loop wrong, right? Or your
Well, that wouldn't happen in this actual call of the insertion sort. It will happen, the worst case will happen if that array comes in sorted in reverse order. Meaning it will take longer time to sort that rather than something that's already in sorted order. Because think of it, for each one, if the first thing is 7, everything before that is going to be less than 7, so it's going to have to swap all the way to the end of the address, and then go back to the beginning and do that for the second one. So now 2 would be at the front, 7 would be at the back, and then it would be 2, 6, 5. So then we would have to do that with the 6, go all the way to the end, go all the way to the front
case,
again.
you don't have to do it because like when you initialize your array of size 5, those 5 numbers aren't in reverse order. They're just random.
They're just random, yeah.
Oh.
So I can do it in reverse order. It will give me the same thing, but it will take a little bit longer, I guess. You won't be able to see it, but
Like the compiling time?
yeah, yes. So that's our insertion sort. We have our complexity. I'm going to rename this study union. Insertion sort. So if you go back to my repel page, that will be there. But it is also in this thing right here, our study union exam solutions. That has the whole code and all the codes in them as well. So going back to our slide. We don't have that much time left. Do you guys want to do one of these functions? Write up one of these, if those are appealing to you. Which one? What was that? First one? Everyone want to do the first one? Let me make a new repel here. This one's not that bad. So let me put our directions in here just so we have them. Write a program that uses a function to generate 5 random numbers in an array and returns that. So first thing we're going to be doing here is actually making our array. I'm going to actually include some more stuff because we're going to need this. Include standard library and include, I'm just going to put time down to h as well because we're going to need that rand function. So what I'm going to do first is declare an array, int array, and I'll just put 5 in here. And we're also going to need a integer pointer so we can point to that array. So I already know that this pointer is going to be equal to the return function of our function. So I'm just going to set that up real quick. And I'm going to pass that array to that function. So now that I have our array name, our function name, I'm going to make our prototype. So this is going to be an int pointer it's going to return. And this was called rand_array. And we are taking in a integer, wrong one, and integer array. Cool. So let's go to our function. Let's make our function now. We already said it's going to be returning an int. Call it rand_array. And the two parameters are going to be our int, we can just call it an array. I think that's the easiest thing to do. So inside here, I know I'm going to need a for loop to go through our array indexes, so I'm just going to put a int I for a counter. And I also want them random, so what am I going to need to include? srand, awesome. And when I include srand, that means all of these random numbers will be actually random, or not really, pseudo-random, but we don't have to go into that. So let's go into a for loop so we can go through our array. I is less than 5 because I know it's just going to be 5 integers in this case. And so how would I assign a array index a random number? I'll start for you. Yes, question.
When you see the rand function, does it work like, does it have a scope?
Does the rand function have scope? I believe so. I believe this should only do srand for that function, I think.
So you just write the rand without shooting it on main.
I believe so. I'm not 100% certain. That's something super easy you can test yourself though. Just put that in a function and then try to do it in main, see if you get the same number. I'm not sure really how the scope of srand works. It would lead me to believe that it would only be here, but. So how do we assign our integers, our indexes to a random value? Zero plus mod 100. Cool. Exactly. We don't need it, but if that helps you look at it, then we can do that. And then I'm also going to do another for loop in here. The same thing, just make that equal to 0 again, and then print these out. So we can see that they are the same value. So I'm just going to do a quick printf, and I'm just going to print out %d space rvi. And then at the end, since this is returning, I'm going to be returning that array back to main. Let's check, see if we have any errors. We do have some errors. Line 14, expected that, okay. So I missed that guy. Cool. But that is not in main, that is printing out in the function. I want to make sure it is still printing out in the main. That is the same thing, the whole point of this pass by reference. So I'm going to print a new line, and I'm going to do another for loop in main, just so I can print them out, check the values. Yes, got my I right there. I equals 0. I know it's going to be only going to 5, so I is less than 5, and we're going to increment as well. And very simple, we're just going to be printing everything out. %d, and now, this is where it gets fun. What am I going to enter here to be able to print out that array that I returned? We just kind of covered it in a similar function or program.
You have to dereference the pointer.
We have to dereference the pointer. So PTR is our pointer. So I'm going to put this in our little brackets here. So I know I want to dereference that thing. Plus I. Just like that. See if we have any errors. And that looks really ugly. See? And we just got different numbers. Ran it again. Those are the same. First line is being printed in the function to make sure we have our randoms assigned and it's actually inside that index. And then in main, we're just seeing that we actually pass by reference and we have the same exact numbers. Yes, question?
Can you just do PTR brackets I? Same thing, right?
So without this, without the dereference, you just want me due to PTR brackets I. Yep. So those two are equivalent, meaning this is equivalent to PTR plus I. So in here, we're just having the brackets, and then there we're actually dereferencing and then adding an offset to our little index. Any questions on this program? This is returning a integer array instead of just a regular integer. And quick question, how would I return more than one thing from that function if I wanted to? Say I wanted to return something that told me how many variables are in that array. I'm already returning something, so I can't use a return statement again. So how would I do that? Exactly. We'll just modify our functions, parameters, and we'll pass by reference. And with pass by reference, we can return almost as many things as we want from a function. That's the other reason it's very, very useful, is we don't have to use that return statement. We can just do a void and return as many as we want. Awesome. Great job. Any questions on this before we get out of here? Nope. All right. We do only have 9 minutes left. We have one more program that cubes a number. May be able to finish it in 9 minutes.
Is that our only option right now?
We can start on linked lists as well, but I don't think we will get far into that. And like I said before, if you go to my repel page, linked lists are here, exam without solutions. I'll delete this repel afterwards, so the other thing will be there with solutions. So basically, yeah, question? Did you have a question?
Yeah, just for the evaluation, what number do you want us to double in?
It might be this 36 right here.
Okay.
I'm actually not sure. I think it might be that 36. Thank you all for coming. Good luck on your finals. Study hard. What?
Wait, but it's not over. Is it?
You can leave if you want.
Oh,
Do you want to go over anything else?
Recording, right?
Thank you very much. Yeah, of course.
Oh, okay.
I was just going to delete this repel so we could see our whole thing. Just so we can. So if you guys go on the repel, you should be able to see these 4 start things. Everything that we went over has a solution. I've coded everything. The true and false don't have solutions, and the linked list is fully coded. It only includes append, prepend, and delete in the back. But this should give you a very good basis on linked list and how they work. And if we run this real quick, we can see, might be a little bit slow on this guy. So I'm going to prepend on this one. So I have 1 in the node, or 1 in the list. So I'm adding stuff to our list, and then I can delete as well. So this has a fully functional, you can look at what's happening as you're running the program, And this is also dynamic, meaning we can modify our linked list and stuff while it's running. Whole purpose of our functions, or our linked list. And yeah, I'm going to go modify this guy so we can see our 4 things. This is our rand array. Awesome, we don't need this. Does anyone have any questions I can answer? Any questions at all? You're good. Yeah, no, it's still there. I was just doing it so when you went to my repel page, you could see everything that's pertinent. Yep, linked lists without solutions if you want to do it again, with solutions if you want to look at everything.
Example. It's not telling us to do anything. That's just an example.
An example of what?
And the linked list is just an example.
Yeah, this is something I code up.
Oh,
This is just something I code up real quick.
it's not asking us any questions or anything.
If you want, you can delete all the functions and try to write them yourself.
Oh,
That's the whole good. You know, once you fork the repel, you can do whatever you want to it. You can add a delete from the front. You can do whatever you want.
okay.
So.
Part of the homework.
What, the linked list? Did you figure that out? Do you have any questions? Any questions? Any final things?
Thank you.
Thank you, sir. Good luck on your final. If you could do an evaluation that's in front, I know we had to wait till the end so we could do it. I didn't realize the questions were asking how I use my time and stuff like that. So if you want to do the evaluations, that'd be great. I'll collect them at the end.
Strongly disagree for all.
Yeah, you could put strongly disagree if you want. If you felt that way, then of course put that. And I just want to end, just give me a few minutes.